On your quiz tomorrow would be a word problem that corresponds to kind of this slope-intercept form. And so this would be a case of what you might see. Okay, if we were taking this word problem, I'm going to do like a couple examples of it. If it says that the sales for a dinner were $1,980 and it costs $4.50 per child and $6 for an adult, describe or show a relationship between how these values could be reached. Okay? If you were looking to do this, you know that the total of the total for the children plus the total for adults has to combine to equal what? 1980. Okay, and so what relationship could you use to find what the total for children is? It's $4.50 per child. So if we call children represented by the letter C, and how much is it per adult? 6 per adult. So we know that that has to equal 1980. And so this would be the equation that allows you to find this relationship. Right? And so when you look at the graph of this, so we're not specifically right now finding a value for anything. You're just finding how are these related to each other. And so if we look at the sketch of this graph, now, why would I only need to look at this portion of the graph? Can you ever have a negative child? No. Some of you might be the negative child. But in mathematical sense, you cannot have negative people, again, objects. So you don't need the whole screen. You only need to see from 0 on for both of these. Okay? And so how might we go about plotting this? Let's call the x-axis, let's refer to that as children. Okay? And let's call the y-axis adults. Okay? What would be the highest number of adults that could possibly attend? How would we find that value? Right. Yeah, and how would we find the y-intercept? We'd let which value be 0?
450 would equal 0.
Okay, so let's let c equal 0. If c was 0, so if that was the case, we could solve this and take 1980, divide that by 6. Okay, and so we get 330. So our top number of adults, this point right here, would be 0, 330. Okay, and so if we took a look at what's the most, so if this was the case, we'd have 0 children and 330 adults. What if we wanted to find what's the maximum number of children? Again, let a equal 0. If a is 0, we could again find 1980 divided by, here it winds up being 4.5. So we could have 440 children and no adults. And so this equation right here, this line connecting these two, gives all the possible relationships that could exist, or combinations of children and adults possible for this dinner. Okay, so this right here would be the graph of it. You only need 2 points to show on this graph. Intercept method or the standard form method would be the ideal one to represent this. Now, what if it then asked you find the number of adults if the number of children is 100? Fine. So again, it's going to be somewhere over here. When there's 100 children. Lauren? Good. So if we plug in 100 for C, so we have, can we do that mentally? What's 4.5 times 100? So you get 450. Okay. Oops. So if we take 450 plus 6a is equal to 1980, and we solve. So we can solve that by taking 1980, subtracting 450 from that. Okay, and we get 1530 is equal to 6a. And now divide both sides by 6 to isolate our a. And we get 255. And so here would be one potential combination. If the number of children is 100, then the number of corresponding adults would have to be 255.